All right, so hopefully everybody did a good job with predictions. And so finally, the last section of the semester is talking about outliers and what an outlier looks like in the context of a linear regression equation and how we're actually going to find it, what role does it play in the linear regression equation, and stuff like that. So again, we've been looking at outliers pretty much throughout the whole semester. And so we're going to use kind of the same rule of thumb that we've been using before. So if something was bigger than two standard deviations away from the mean, that was going to be what we, kind of our outlier thing for regular data. So the same thing's kind of true when we're talking about it in terms of regression equations as well. So we're looking for things that are going to be two standard deviations above or below the regression line. So graphically, kind of what this would look like, and I'm not going to focus on the graphic part, I'm going to focus more on the algebra part. But say this was our regression line. Let's first assume it's a line, so because that's not much of a line. So let's assume this was our regression line here. Well, then what we're going to find is going to be two lines that are going to be two standard deviations away from the line itself. And what we're looking for is we're trying to see if there's points that live outside of this dotted line. So if there's any points that live outside of that dotted line, those are going to be our outliers, and those are going to be the ones that we have to deal with. So if we're lucky and all of our points live in between those two dotted lines, then that's perfect. There's no outliers in our data and things like that. So first off, why are outliers important in this section? Well, remember the way we calculate our regression line is based on the means of both the x variable and the y variable. So we're actually calculating two means. And if you remember, the means use every single data point. It's not like the median where it only looks for the middle and it isn't influenced by outliers. The mean uses every single point, so it is going to be influenced by outliers. And since we've got two different variables going on, it could be affected two different ways. So it's kind of twice as bad of the things that could happen to outliers in this section and stuff like that. So when we're trying to find the standard deviation, this isn't a standard deviation that we've been looking at before. We're actually trying to find the standard deviation of, let me get the highlighter, of what's called the residuals or the errors. So if you remember from our picture, I'm trying to sketch it here. So this is going to be those red lines that are like, so these guys are our actual correlation or our points that form our regression line. So these y values are really what we're looking at. So the point up here is the actual y. The point on the line itself is going to be the y hat. And what we're looking at are the difference of these y minus y hats. So same thing down here. We're looking at this y minus y hat. And so we're going to calculate all these residuals and find the standard deviation of them. So that way we can figure out how long this line has to be. So now the only downside to this section, so this one's going to be a little bit more work than we've been doing in the past, is because we've got two variables and our degrees of freedom are n minus 2, we can't use 1 var stats as a way to actually calculate this because we're dividing by n minus 2 instead of dividing by n. So we can't use our normal way of finding the standard deviation. So unfortunately, we're just going to have to brute force this guy out to find our standard deviation. So it's not terrible, but it does take a little bit more work than normal. So here's our formula for our standard deviation. So S equals the big square root of the sum of those residuals, the y minus y hat, all squared. So again, we want it squared because we want the positive values. And then we square root it to shrink it back down and make it the right size. And then the n minus 2 again is going to be our degrees of freedom because we've got two variables. So identifying outliers numerically. So again, what we're looking for is we're trying to figure out when this residual is either smaller than 2 times the standard deviation or bigger than 2 times the standard deviation. So again, if you think about our normal curve, it could be either on the upper end or the lower end. So that part's actually not that bad once we've actually calculated the standard deviation. The hardest part of this is actually calculating the standard deviation. So let's jump in, and I'm only going to show you a few of these and then kind of fill the chart out. So once you get the idea, because I don't want to bore you like going through all these calculations because it gets kind of hectic and stuff like that. So first thing we have to do is we have to use our regression equation to, oh, and this is actually a totally different example. So I couldn't use my house price example because that regression equation was so good. There were no outliers whatsoever. So this is totally brand new data that I had to come up with to get an outlier and stuff. So this, we haven't seen this data before. This is brand new. So our linear regression equation is the 4.83x minus 173.5 with a correlation coefficient of 0.663. So, and we'll need that later, not for the calculation, but just so we can kind of compare the new R value we get to the compared to for later on. So we're not going to use that right at the moment or anything like that. But so the first thing we need to do, oops, is we need to fill out our y hat table, which is just like we did before. We want to take that 65, plug it in for x, and see what we get. So in this case, we're going to get y hat equals 4.83 times 65 minus 173.5. So again, let's throw this in the calculator real quick. So 4.83 times 65. Let's see, what was it? Minus, I forgot already. 173.5. So 140.45 looks to be our answer here. So it's a little different than what I had in my chart, so that's not good. So let's see, so 140.45. Oh, I may have done mine without so much rounding. Okay, well this could be bad, so I could end up getting totally different answers here. So what was it, 140? 0.45. And so now what we want to do is do the exact same thing. We want to put 67 in, 71, 71, 66, 75, 67. Now there is a trick that you can do to make life a little bit easier on the calculator, so that way you don't have to plug these each and every time. So if you go to your calculator and go to y equals, then what we can do is actually enter this equation in, and then if we wanted, we could graph it and all that kind of stuff. But I want to just use the table aspect of this. So I want to do, oh, now I totally forget what the equation was again. 4.83x minus 173.5. So 4.83x minus 173.5. And then enter. Let's make sure I got that right before I move on. No point in getting bad data. 173.5, perfect. And so the nice thing is, if you go to hit table, oh, I've got it all messed up. So hold on. If yours looks something weird like that, then that means you've got your table setup messed up. So if I go to table setup, so in this case, usually you want it to be a whole number, so like 0 or something like that, and you want this to be 1. Now, table start, that allows you to jump around wherever you want to. So if I notice all my values are in the 60s and 70s, so there's no point in starting at 0 and then having to scroll the whole way up to it. So I might as well just jump straight to 65. And then now when I go to table, I can see that this takes me right to 65 on my table. And so then I can kind of bounce around, filling out all these different values and stuff like that. So I can go through, and I think 66 was on there, so 145.28. So 145.28. And then 67's on there, so let's grab 67. So 150.11. And there's another 67. Okay, so there's no 68, but there is a 69, so let's grab 69. Let's see, 159.77. And then, let's see, think I got all the 60s now. So let's jump to, we got a 70. So let's grab 70. So 70 is 164.6. And then I got a bunch of 71s. So let's get, and that might be, oh, and then 175. So let's get the 71s here. So 169.43. And then finally 75 gives me, so I have to scroll up. So 75, 188.75. All right, so that's the first thing you have to do is fill out that whole table first. And so now what we want to do is actually go through and subtract all these y minus y1s as the next step. So 175 minus 140.45, 133 minus 150.11, and stuff like that. So again, let me go offline here because the values I wrote down in my table, I must not have rounded, so I've got like totally different values in my y hat than what I've got here. So I don't want to mess anybody up. So let me stop this at the moment, fill the rest of the table out, and then we'll go from there to finish this guy up.